Volcanoes, fiery mountains spewing molten rock and ash. These natural wonders are both awe-inspiring and terrifying, capturing the imagination of people throughout history. From ancient myths to modern science, volcanoes have always been a subject of fascination and fear. They are a powerful reminder of Earth's raw energy. The sheer force of a volcanic eruption can reshape entire landscapes in a matter of hours, demonstrating the dynamic nature of our planet. The smoke and ash that billow into the sky can travel thousands of miles, affecting weather patterns and air quality far from the eruption site. While often destructive, they are also creative forces, shaping landscapes and influencing life. New landforms such as islands and mountains emerge from the ocean, providing new habitats for various species. The rich volcanic soil is incredibly fertile, supporting lush vegetation and diverse ecosystems. But what happens when this power turns catastrophic? The same forces that create can also destroy. Violent eruptions can obliterate entire ecosystems, leaving behind a barren wasteland. The ash clouds can block sunlight, leading to a temporary cooling of the Earth's surface, which can have far-reaching effects on global climate. What happens when volcanoes push life to the brink? The immediate aftermath of an eruption can be devastating for local wildlife and human populations. Animals flee in panic, and forests are buried under layers of ash. The long-term effects can be equally severe, with disrupted food chains and altered habitats. Throughout Earth's history, volcanic events have triggered mass extinctions, forever altering the course of life. The fossil record shows us that some of the most significant extinction events were caused by massive volcanic eruptions. These events released enormous amounts of gases and ash into the atmosphere, leading to drastic changes in climate and the extinction of many species. These events, marked by massive outpourings of lava and toxic gases, paint a stark picture of nature's capacity for both creation and destruction. The lava flows can cover vast areas, while the toxic gases can poison the air and water, making it difficult for life to survive. Yet, over time, these same areas can become rich habitats, teeming with new life. Understanding these past events is crucial for comprehending the fragility of life and the potential threats our planet faces. By studying volcanic activity, scientists can better predict future eruptions and develop strategies to mitigate their impact. This knowledge is essential for protecting both human populations and the natural world from the potentially catastrophic effects of volcanic eruptions. One of the most significant volcanic events in Earth's history is the eruption of the Deccan Traps. This event, which occurred around 66 million years ago, was not just a single eruption, but a series of massive volcanic activities that spanned nearly 1,000,000 years. The Deccan Traps, located in what is now India, is one of the largest volcanic features on Earth. This colossal volcanic province in India erupted for nearly 1,000,000 years, spewing out unimaginable amounts of lava and gases. The lava flows from these eruptions covered an area of about 500,000 square kilometers, which is roughly the size of modern-day Spain. The volume of lava produced is estimated to be around 1 million cubic kilometers. The Deccan Traps eruption coincided with the extinction of the dinosaurs, making it a prime suspect in their demise. While the asteroid impact in the Yucatan Peninsula is often cited as the primary cause, the prolonged volcanic activity of the Deccan Traps likely played a significant role. The combination of these catastrophic events would have created a hostile environment for life on Earth. The sheer scale of the Deccan Traps eruption is difficult to comprehend. Imagine rivers of molten rock flowing across the landscape, burying everything in their path. The eruptions would have created vast plateaus of solidified lava, transforming the geography of the region. Lava flows spread across vast distances, covering an area larger than Europe. These extensive lava fields are a testament to the immense power of the volcanic activity that created them. The landscape we see today is a stark reminder of the Earth's dynamic and sometimes violent geological processes. The gases released, including carbon dioxide and sulfur dioxide, would have had a devastating impact on the environment. These gases would have contributed to a dramatic shift in the climate, leading to a phenomenon known as volcanic winter. The sulfur dioxide in particular would have formed aerosols in the atmosphere, reflecting sunlight and causing global temperatures to drop. The atmosphere would have choked on toxic fumes, while acid rain poisoned the land and sea. The acid rain resulting from the sulfur dioxide emissions would have led to the acidification of water bodies, harming marine life and disrupting ecosystems. The combination of these environmental stresses would have made survival difficult for many species, contributing to the mass extinction event. Long before the dinosaurs, another even more devastating extinction event shook the planet. This event, known as the Permian Triassic extinction, occurred around 252 million years ago, and is often referred to as the Great Dying. It was the most severe extinction event in Earth's history, wiping out a staggering number of species and altering the course of life on our planet forever. The Permian Triassic extinction, also known as the Great Dying, wiped out an estimated 96% of marine species. The oceans, once teeming with life, became desolate and barren. Coral reefs, which had been vibrant ecosystems, were decimated, and countless marine creatures perished, and 70% of terrestrial vertebrate species. The land was no less affected. Forests withered, and vast stretches of the earth became uninhabitable. The fossil record from this period shows a grim picture of a world in turmoil, with skeletal remains scattered across desolate landscapes. The culprit? Massive volcanic eruptions in what is now Siberia. These eruptions, known as the Siberian Traps, were among the largest volcanic events in Earth's history. They spewed lava across vast areas and released enormous quantities of volcanic gases into the atmosphere. These eruptions released colossal amounts of greenhouse gases, leading to rapid global warming. The atmosphere became thick with volcanic ash and gases, creating a greenhouse effect that caused temperatures to soar. This sudden and extreme climate change had catastrophic effects on the environment. The oceans became acidified, and oxygen levels plummeted. Marine life struggled to survive in these harsh conditions. The acidification of the oceans disrupted the delicate balance of marine ecosystems, leading to widespread die-offs and the collapse of food chains. The result was a planet on the brink, struggling to support life. On land, plants and animals faced equally dire circumstances. The once lush and diverse landscapes were transformed into barren wastelands, and many species were unable to adapt to the rapidly changing environment. The Permian Triassic extinction stands as a stark reminder of the devastating consequences of extreme volcanic activity. It serves as a powerful example of how quickly and dramatically the Earth's environment can change, and the profound impact such changes can have on life. This event reshaped the course of evolution, paving the way for the rise of the dinosaurs and ultimately, the world we know today. Volcanic eruptions are just one of many ways Earth can experience a mass extinction. Asteroid impacts like the one that wiped out the dinosaurs are another dramatic example. These events cause widespread devastation, often leading to rapid climate change and ecological collapse. Ice ages, on the other hand, represent a slower, more gradual form of extinction. As temperatures drop and ice sheets expand, species are forced to adapt or face extinction. While less dramatic than volcanic eruptions or asteroid impacts, ice ages can be equally devastating over time. Section 5. The Sixth Extinction. A modern parallel? Today, many scientists believe we are in the midst of a sixth mass extinction. However, unlike past events, this one is driven not by natural disasters but by human activity. Habitat destruction, climate change, and pollution are pushing countless species towards extinction at an alarming rate. The current extinction crisis serves as a stark warning. While we may not be facing a single catastrophic event like a volcanic supereruption, the cumulative impact of our actions is pushing the planet towards a tipping point. Section 6. Volcanoes and climate change. A complex relationship. Volcanoes and climate change are intertwined in a complex dance. While large eruptions can inject massive amounts of greenhouse gases into the atmosphere, contributing to warming, they can also release aerosols that reflect sunlight, causing temporary cooling. Understanding this complex relationship is crucial for predicting future climate scenarios. While we cannot prevent volcanic eruptions, we can study their past impacts and develop strategies to mitigate their potential consequences. Section 7. Monitoring and mitigating volcanic threats. While we cannot stop volcanoes from erupting, we can try to be better prepared. Scientists constantly monitor active volcanoes around the world, looking for signs of unrest. Early warning systems can give communities time to evacuate before an eruption, saving lives. Research into geoengineering technologies is also underway. These technologies aim to counteract the climate impacts of volcanic eruptions, for example, by removing excess carbon dioxide from the atmosphere. Section 8. Lessons from the past, hope for the future. The history of volcanic eruptions and mass extinctions is a sobering reminder of Earth's power and the fragility of life. However, it is also a story of resilience. Life has an incredible ability to adapt and recover, even after the most catastrophic events. By studying the past, we can learn valuable lessons about the potential threats we face and develop strategies to protect our planet and ensure a brighter future for all. Section 9. Conclusion. Respecting Earth's power. Volcanoes, with their awe-inspiring power, have shaped our planet and its history. They are a reminder of the delicate balance of life on Earth and the potential for both creation and destruction. By understanding the past, respecting Earth's power, and taking action to mitigate future threats, we can strive to create a more sustainable future for all.